Hey guys, how's everybody doing? If you're watching this, it's because you read my email and you know that I will not be able to conduct a lecture in person today. I know some of you are probably very excited about that, so that's great. The reasoning behind it is dual because I have a military thing I have to take care of. So I will not be able to be in class. However, we will still conduct our lecture through this medium. Of note, just know that we will do the Module 4 labs together next week in class, okay? So let's get started, okay? So we started with Module 1, understanding what an operating system is. We know that an operating system is the way that we interface with the hardware in our computers. It's how we operate the systems, right? We learn about all of the different tools that we can use to manage individual systems. The Microsoft Windows OS is the Yoga OS in that it offers a lot of flexible options for you to manage individual systems. Well, that also extends to multiple systems, how we manage a network of systems. So that's kind of what we're going to go over today. Networking these devices. We briefly touched on it during the past couple of weeks. We learned about the differences between peer-to-peer and AD joined or networks computers. We used the analogy of the cruise. Peer-to-peer is when everybody is going to the cruise, you and all your friends. No one's really in charge. Resources are given out on a first come, first served basis. Whereas in an Active Directory domain join the network, there is, one person or one domain controller who manages access to all of the different resources in the network. Okay, so we are just going to go deeper into that subject. That's what Module 4 hits. Okay. So by the end of this module, you will have an understanding of all of the different components, physical components that are involved in networking Windows 10 machines or just Windows machines. That includes the difference between the different Internet Protocol versions, which you've already probably heard of, IPv4 and IPv6. We will learn how to connect Windows 10 to the Internet, which you're already doing if you're watching this video. We are also that's going to extend into wireless networking and the different types of signals. And then finally, we're going to learn how to protect our systems through the Windows Defender firewall. Okay. At its core, the basic components of Windows 10 are managed through different places. Within the Windows UI, the user experience, the user systems, the GUI, the graphical user interface. That will be the network and internet settings, and then the network and sharing centers. Not only do they show us what our current status in our network is it active, do we have internet, are we connected physically, are we connected through wireless, but it also gives us troubleshooting tools. In case those connections are not behaving as we expect. There's also a remembered network section, which, just like it sounds, and I keep going back to saying that IT is kind of easy, right? Because all of the names are pretty intuitive. You will see a list of all of the networks that you ever connected to include the settings. Windows does that, which I'm sure you already know, is for expediency, so to make it easy for you to connect in the future. Okay. We'll start with networking settings. The network and the internet settings page can be accessed by just clicking on your task on your start menu, and just go into settings. And this is the way that Microsoft wants you to access it moving forward. Microsoft gives you a lot of legacy options, meaning old ways of doing it through like the control panels, which we'll discuss. But within the network settings, you're going to find your network status. You also have access to advanced network settings. So not only will it tell you, are you connected, but what are you connected to? How are you connected to that medium? And also what's your specific IP address? What gateway or what route are you taking out to the internet or to that other device, and all of the troubleshooting tools that we already discussed. This is kind of what it looks like. Again, you just go into Start and then go to Settings, and you'll be met with something like this under Network and Internet. So in this specific case, we are connected to through Ethernet, which means through a cord to the internet. If we click on Show Available Networks, if we were connected wirelessly, we would be able to see the list of networks. If I clicked on Change Adapter Options, and in there I'll be able to see my specific IP address, what is the status of the adapter or the physical device that I'm connecting to, and also all of the troubleshooting features. You'll also see Windows Firewall, which we're going to discuss a little later. Okay. The Network and Sharing Center is where we would change the configuration of the network that we're currently connected to. And within it, we can see all of the different active networks. So like we mentioned, we click on wireless and we can see everything that's available. And from there, we can change network settings. Among those settings are our IP address, which is kind of like our name that each computer has, is a logical name or a logical set of numbers called octets that are assigned to every single machine. And we'll touch on that in a moment. This is what the Network and Sharing Center looks like. Of course, this is through the control panel, which is the legacy way of accessing network settings within Windows. But we can see pretty much the same information that we would typically see if we were in a different, if we were using the settings menu. We see the status of your connection. So we can see here that we are currently connected to a public network number 4, that we are connected through Ethernet, and here we have the very same troubleshooting tools that you would have just by accessing through network settings. And notice down here, you can also see the firewall, that we are a place where we can go to change the firewall, which is what we use to protect our networks. In the remembered networks, we, like mentioned already, Windows saves every network configuration that you connect to, just to make it easier for you to be able to connect in the future. On top of just connecting, it remembers every of the name. Remembering the name, it also remembers every single password and your preferred method for connecting to that network. Within it, you'll see the name, you'll see the ID. If it's a private network, if it's a public network, if it's a domain network, so like something internal. We also use a tool called Network Discovery that not only allows you to connect to that network, but also allows you to view what other computers are on that network and what other resources are on there. You have an option to turn Network Discovery on or turn it off. That's just in case that you don't want to be discovered by other machines on the network. Okay. So within each connection, we have a way of determining what language it is that we're going to be talking. So how we are going to be communicating with the sources. And we do that by right-clicking on the adapter and clicking on adapter properties. So if we would have gone back and clicked on Ethernet properties, so the properties of that adapter, we get to see that this specific one is connecting through a IPv4, which is just, we'll talk about addressing in a moment, but we know that we have the capability to communicate with file shares and printer shares, and we also have the ability to connect to IPv6. So it's think of it as, I have a network adapter or something that allows me to connect to a network, and you can specify how that adapter communicates with the rest of the devices on the network. Okay. All right. So when it comes to connections, each connection allows the systems to communicate through what's called clients and services, and those are the individual applications that the network uses to communicate. I always go back to gaming, right? Like, if you guys have an Xbox or you have a PlayStation, the Xbox network or the PlayStation service allows you to communicate with the PlayStation servers, which enables the communication with all of the different PlayStations all over the world, and to include those servers that we mentioned for various services like purchasing, authentication. Um, so each service allows your computer to accept those connections. So it decides based on the security settings that you have whether other computers are going to have access to you. Not only that, but also those services allow you to decide whether you're going to have access to the resources that are available, to include the aforementioned printers and file shares. Um, these languages that those services use are called protocols. The protocols are the rules for communicating across a network. So now if we break it down, we think first we have the actual device itself, then we have the service that's using the device, and then we specify how that service is going to communicate, and that's our protocol. So they define how much data can be sent and also how that data is formatted to be understood, i.e. you and I are talking through this video and I am speaking English. English is my protocol. Okay. Windows supports many different types of protocols, but along a couple is IPv4 or TCP, which is transmission control protocol. So it dictates how the systems are communicating. We'll talk about that in a second. The link layer topology discovery mapper and responder, which is used to discover resources in the network. All right. I know you guys by now know fully what a driver is, right? If you think of a driver, you think of a bus, right? Every bus needs a bus driver. The driver is what makes the hardware perform its function. It was what makes it move. If not, it would just be an empty piece of plastic. So that's what the driver. Well, network devices also have drivers. No surprise there, right? Okay. So what is TCP/IP, Transmission Control Protocol, Internet Control version 4? And what happened to version 1, 2, and 3, and 4? You're probably asking yourself. Well, don't worry about any of that. Just know that it was eventually developed. The internet was developed for military applications by Al Gore. Apparently had a whole bunch to do with it. But it is the most, once it got to version 4, then it became public. It is the protocol that we use to be able to communicate across network devices. I know that you're probably wondering about the 6. Well, the 6 is just a more advanced version. But TCP/IP version 4, it's the most popular networking protocol, and it is currently included with every single version of Windows, to include Windows 10, Windows 11. IP addresses are essentially the logical names. When I say logical name, I mean this is an iPhone, right? But this iPhone is Roberto's iPhone, so my iPhone. So Roberto's iPhone is the logical name. So each computer also has a logical names that they identify with, which is an IP address. And every single address on a network, I'm sorry, this pen thing here is not really working. IP address on the networks are all unique, right? Two devices cannot have the same IP. They are displayed as 4 decimal numbers called octets. So here's 1, 2, 3, and 4. So these are 4 decimal numbers. They're called octets because they each can be represented by 8 different bits. So a 5, if I take zeros and ones, so you just think of zeros and ones, 0 as a bit, a combination of zeros and ones, 8 bits long, will give you that specific number. The value of the first octet tells you the class of IP, and we will go into the different classes in a sec. But it tells you what kind of class it is. So the first octet, meaning this specific set of numbers right here, tell you the class, and there are a couple of different classes which we will discuss. Okay, if the first octet is 0, the remaining octets identify local machines on the network. So it just tells you that if you see an IP that starts with a 0, it's just telling you that it's all of the local machines. If it's a 127, so if it starts with 127, that's called as a loopback address. A loopback address is basically you're sending a signal, but it's like you are it's coming right back to you, and we use it to test the individual networking components of that system. So if I am troubleshooting why I can't talk to you, I'm not gonna first try to talk to. I'm not gonna first try to test out the connection, right? The air, right, of which I am speaking to you. I'm first gonna make sure my mouth works. So you will use your loopback address in order to verify that your specific components are actually working. Okay. Several ranges of IP are reserved for only internal use only, and that's through something called a NAT. So internally, when we are inside of a network, we are communicating out, right? We are communicating out, and I'm sorry, within the network, we're communicating with each other. But once we go out into the internet, where there's like so many different computers, right? You're gonna have to understand that you're gonna encounter some IPs that are gonna be very similar to yours. So we need to turn our internal IPs into IPs that will be able to exist alongside IPs out in the open in the world. So we use a service called network address translation, and that takes an internal private IP and turns it into a public IP out in the internet. So when it leaves your house, so when it leaves your business, it's getting natted. It's going through a NAT process that turns that internal IP and turns it into something public. As we mentioned, the different classes, that first octet tells you what classes. Class A is anything 0 to 127, which we described as the loopback. Class B is 128 to 191. Class C is what you typically see in internal networks, private networks, and that's 192 to 223. And then we have Class D and E, which here you can see in the table is 224 to 239, 240 to 255. I will go into what we use those for in just a moment. So if you guys have ever seen IP addresses that end in like something slash, that's called the CIDR notation. CIDR notation lets you know how many spaces, how many octets are reserved for the actual network. So for the actual computers and devices on the network. So here we see, for example, 192.168.0.0, right? Each of these octets represents 8 bits. So this is saying 16 bits are reserved for all of the devices on the network. That means these last 2 bits right here are reserved. So then an example of that would be like, I have a computer that starts with 192.168.1.2, and then you would have a computer that would end in 192.168.2.3 or that 1.3, right? The only thing that changed was those like 2 octets, because that indicates that lets me know that the first 2 octets never change. Okay, that identifies my network. The last 2 octets are identifying the devices on the network. Okay. Now we are going into something called a subnet mask. What is a subnet mask? A subnet mask lets you know, just like we mentioned by that CIDR, what part of the IP addresses belongs to the network to let us know what network ID we have, and what part of the address is for the host or for each individual computer within the network. Okay, it's just a quick way for us to be able to look at an IP address and be able to determine. So, for example, if you like cars, you have a, I don't know, give me a car, a BMW. I have a BMW. The BMW lets me know that I am buying a vehicle from BMW. The model of the vehicle, so a BMW M3, M4, tells me what specific version of the BMW I am buying. So what is the company and what is the vehicle? Okay, that's what a subnet mask allows us to do. You probably have seen subnet masks that'll and without even realizing it, but it'll tell you 255.255.255.0. Well, that subnet mask lets me know that the first 3 octets 255, sorry, 255.255.255 belongs to the network that identifies the network. So it could be, and then that last one belongs to the actual device on the network. Okay. So here's an example: 172.116.34.116, right? So this 16 tells me that these two octets right here are for the host. Okay, so host, and then these two belong to the network, right? That's what that /16 tells me. So the subnet mask for that one would be, since we know that the first two are for the network, we know that these two are for the host. The subnet mask for this would be 255.255.0.0, right? It's just a quick way to be able to look at it and say, without looking at the CIDR, and let you know what bits belong to the network and what bits belong to the host. Here's another table that kind of lays this out pretty easily. So we know in this is a -18, so that lets me know that I'm sorry, this is for the subnet max value. This lets me know that my subnet mask, so a 255/8, lets me know that the first 8 bits belong to the network and the rest of them are for the host. A /16 subnet max lets me know that the first 2 octets belong to the network, and then the last 2 are for the host. And same thing here with 24/8 plus 16 plus 24. This is all network bits. Okay. What are gateways? Gateways, simple. It's your router. It's what you use to get out into the world or get out into the system. Having a quick Diet Coke. What you use to get out into the world, right? What is the device that you go to? Your gateway. Typically, they're routers. They control the movement of the packets of the data throughout the network. Usually, you have a default gateway. So your default gateway will be the default device that you use in order to leave or just maneuver throughout the network. Windows 10 usually stores that default gate setting in something called a routing table. So it'll learn how is it that you move through the network and what you use in order to move to the network, and then allows you to move to using it. It's called the routing table. So what is DNS? So the domain name system. The domain name system is an essential protocol that we use in order to communicate through the network. If I wanted to talk to you and all you knew was my IP address and you had to memorize like 4 octets, that'd be kind of difficult, wouldn't it? It's not something that's really human readable, so it makes it very difficult for me to communicate with you. Well, Windows uses something called the domain name system that takes that IP address of that device and it actually translates it into a name. So this isn't device 192.168.256.1. This is Rob's iPhone. So it just takes that IP address and then it converts it into a name. Okay. Windows 10 also has a file in a folder called host, a text file that tells you, that records all of the different IP addresses and then resolves it to different names in case you wanted to visit it. Okay. Now what is the WINS, which is the Windows Internet Naming Service, or WINS? It's old technology. It's old technology that used to resolve what are called NetBIOS names to IP addresses. So think of the DNS as the new hotness, okay? But it used to take your IP addresses before, as it was coming into the network, and resolve it to an actual name and vice versa. But Windows being as backwards compatible as it is, just kept that there so that these devices could communicate. Okay. Now, how do we configure IPv4? All right, we know what it is. We know that IPv4 is a way that we can assign IP addresses to devices. How do we actually configure this stuff? Okay, so doing it manually while in some cases useful in understanding it, it's not very efficient. I can't go to 50, 60 computers in a network and then immediately try to uh, assign an IP to each one by jumping into one. So I'm not gonna do that because again there's 50 of them and there's one of us. So we're gonna use something called DHCP, which is the Dynamic Host Configuration Protocol, and it is an automatic way. As soon as the device has connected to the network, the DHCP service gives it an IP address. It assigns it a subnet mask. It assigns it a default gateway. It assigns it a DNS and a Win server to resolve those IP names, to be able to shoot it out, so that they can communicate. And it does that automatically. So if you ever seen it where you've enabled DHCP, DHCP is that service. Okay. Within DHCP, there's a certain amount of addresses called a PIPA addresses, automatic private IP addresses. And that's just for very, very small networks. It's usually addresses on the 169.254-16 networks. Very small IPs that don't require any type of internet connectivity. Windows 10 also allows you to configure a static set of IP configuration. So you have a choice of using DHCP if you have a very large network and setting up a DHCP server that assigns these IPs, or you can have a static IP where you decide to assign to go in and do it manually. Okay. In order to assign an IP, you can use something called NetSH, and that allows you to assign a static IP to a network interface. It's actually one of the things that we'll be doing in our labs. Okay. Different ways of assigning a static IP, Windows being the Yoga flexible operating system. You can right click on the Ethernet adapter and be able to assign the IP address. You can assign the subnet mask. You can assign the gateway. Or you can click here and you can have DHCP. Click that and DHCP does it. You can also do it to the network and internet sharings. Same thing. Or through the control panel by accessing this specific windows here that just allows you to configure it manually. Okay. Now, within our command line, there are a bunch of different tools. Command line, the black and white box that allow you to also configure it. We have hostname, which hostname displays the actual name of the box. Remember, we take an IP and we turn it into a box. IP config, that shows the current configuration. You can go into your systems right now and type in IP config and you can see your exact IP address, your subnet mask, everything. Ping is used to communicate with all of the different devices and just test network connectivity. Tracert gives you the same information that ping does, but it tells you how many hops it has and what devices it's touching on the way there. I.e., I want to go to Starbucks, but on my way to Starbucks, I'm first going to stop at Kroger. Then after Kroger, I'm going to go get a haircut, and then I'm going to go to Starbucks. So that's what Tracert does. Path ping is kind of the same way, except that it sends a lot more pings just to make sure that I'm there. Route will show you what's in your routing table, so all of the information that your device has recorded, so that it can get around the network. Netstat will give you specific statistics about the network connections. So what's happening in the network, how many packets are communicating, who are you communicating with, and also and also the frequency of connections, and what ports and protocols. And MBT Netstat, it's something that we used to use with the legacy system NetBIOS. Okay. There are some additional tools like GetMAC. A MAC address, like we already discussed, is the actual physical address of all of your devices. That is the physical name of your connection devices or your network adapters, or of your device. ARP is the address resolution table, and that takes it's like a table that has all of your IP addresses, and then it maps it to whatever the MAC address is for that address. So that allows your systems to more effectively communicate. I not only know that you are Roberto, but I know your exact DNA, and I can find you in a crowd, or in this case, a basic network. NetSH modifies all of the network configurations. which we discussed. We can do that to assign specific configurations. And NS lookup allows us to look at those DNS records to be able to tell what IP resolved to what. That's actually useful in a security setting when we want to make sure that we're communicating with the people that we want to communicate, or with the devices that we want to communicate, because those DNS records can be poisoned, and they can change who it is that you're communicating to and resolving to. Okay. Within ipconfig, there's different modifiers that you can use if you want to see every single thing about your configuration. It'll be a lot more verbose and more detailed. You put a/all. A/release will release the IP address that was assigned to you dynamically. That way you can reset it or just get another one. Renew it. It renews all of the network connections to that specific IP, so that you can also grab a new one from a DHCP server. You have registered DNS, display DNS, and these allow and flush DNS, and that allows you to view DNS information and register your particular device with the DNS server, so that other devices are able to find it a lot more easily. Display DNS shows you all of your DNS configuration, and then flush DNS takes all of the information that's stored in your DNS server and it just flushes it out so that you can provide it with new one. Typically, you would do this backwards. You would go flush DNS, make sure that you don't have a DNS setting, and then register a new one in case you're having some kind of connection issues. Within ping, we have ping T, ping A, ping N, ping 4, and ping 6. Ping tag T will continue to send that ping in and out to troubleshoot that connection. Ping tag A will do a reverse DNS lookup to kind of find out what is the fully qualified domain name that's associated with the IP address of the device that you're using. With ping tag N, you can say, I only want to send 50 signals to verify that I'm there. So you put tag N and then the number. Ping tag 4 forces it to use IPv4, and ping tag 6 forces it to use IPv6 to connect. Again, we're going to go over IPv6 in a moment. Okay. All right. So now then we have netstat. Netstat tag A, tag E, tag R, tag B, and tag O. Tag A, and just wherever you see tag A apply to a command, just think that it's going to give you the most invasive and active way of enacting that command. So netstat tag A displays every single connection that you have that your computer is connected to include the ports and protocols that it is connecting through. Tag E will give you the statistics, how many packets have been sent out, how many have been received. Tag R shows you another way to see the routing table to see what paths are being taken and how Windows is recording those acts. Tag B displays the name of a program responsible for that specific connection, so it's assigning a specific connection to a service that's communicating out. And then tag O will show you what is active or waiting a connection. That's kind of useful from a security mindset because you could detect potential beaconing activity from your system to some kind of malware server somewhere, which is bad. Don't do it. Now we're going into some PowerShell commands that kind of accomplish the very same thing. So PowerShell, we know it's PowerShell because, again, this is verb and this is a noun. So clear DNS client cache does exactly what you think it does. It clears the cache from DNS to DNS server. Getting DNS client cache is going to retrieve all of those DNS records. GetNet adapter will tell you all of the different network adapter properties. Net IP address, IP configuration, that's similar to IP config, so it's going to tell you your subnet mask, all of that great info. And then we have commands for both IPv4 and IPv6 configurations. Okay, some additional ones are GetNet TCP connection, and that shows you all of your current TCP IP connections, and that includes how you're connecting locally and remotely to other IPs. New net IP address that creates and configures a brand new IP address using the same naming convention that you've used. You can remove it. You can also use resolve DNS name to take a specific name and then resolve it to an IP. It's similar to another command that we use called NSLOOKUP, which takes a name. Let's say that we'll say this is Rob's iPhone, and if we wanted to know the specific IP address associated with my device, and that would give you that IP address. And then specific IPv4 and IPv6 configurations to set, where you can set specific settings within each of those protocols. And then here's a way to test the connection by using test net connection. And that is essentially giving you the same functionality that ping will give you, ping and tracer. So can I connect to the device? And what devices am I hitting along the way to that connection? All right, so now that we understand more or less what an IP address is, we know some commands that are basically allowing us to troubleshoot that to configure that connection. Now, how do we troubleshoot it? So we have a couple of tools. We mentioned NetSH and IPconfig to view the current configuration, and also NetSH to modify it. First thing we want to do is we want to make sure that the system we're trying to communicate to has the IP address that we think it does. So we use IPconfig. And if it doesn't, then NetSH. Once we have already configured it, then we ping it just to make sure that I can read it, or that I can see it, that my device can see that specific device. If that's not working and it's going through a DNS server, we want to make sure that we confirm that the DNS server is configured correctly in order for the IP, the host name of that device is being resolved to its actual IP. So I am trying to communicate with this Coke can, right? And all I'm telling the DNS server is I want to communicate to the Coke can. Well, the Coke can needs to have the DNS server needs to have the a table that says this is a Coke can, and the IP for the Coke can is 192.168.1.2, not 1.3. So verifying that our DNS servers are configured correctly is extremely vital to maintaining a healthy connection. All right. Finally, we want to check to make sure that our firewall is configured in a way that it is not blocking our connections. So firewalls have rules. They decide what gets in the network and what doesn't get out. So we have to make sure that they're not in a state where they're blocking. There's some kind of rule that's blocking it. So once again, ping. Make sure that you're configured the way you think you are. Ping it to verify. Confirm that if you're going through a DNS server, that the DNS server is configured with the right host name to IP address table, and also just verify that your firewall isn't set up to block it. Okay, so we've now reached our first knowledge activity, knowledge activity 1. What provides you with a way to control how your computer views other computers on the network and advertises its presence? All right, so the key here is advertise presence. And we know that we learned that network discovery is what allows us to what allows other computers and other devices on a network to kind of view where we're at, that we're actually there, and allows us to see other devices on the network. There we go. Network discovery provides you with an easy way to control how your computer views other computers on the network and advertises its presence on the network. Okay, so we hit IPv4 pretty heavily. We understand what it is. We know that our computers have names, and they also have a logical number assigned to them. We know how IPv4 works. We know that the subnet mask lets us know out of those four octets, which ones belong to the network and which ones belong to 6. So here's what happened, right? Excuse me, a long time ago, drinking Coke, I'm getting gassy. A long time ago, we came up with IPv4, and there weren't that many computers in the world as there are now. And somebody that said, you know what, this isn't going to be enough. the IP spaces, the range of IPs that we can have is not big enough for all of the computers that will exist in the future as we become exponentially more connected. So they developed IPv6, which at its core is just a more complicated and complex numbering system that allows for exponentially way more computers to be connected into the world. So that increase the IP space. It also has a way of routing that reduces the load on all of the different routers, the way that it is communicated, and it improves the quality of the service and the availability of those connections. IPv6 address notation is drastically different from IPv4, where we have 4 octets that are 64-bit longs, right, in IPv4. IPv6 addresses are 128 bits long. So you can have a lot more addresses, and the reason is not just because you can add additional numbers, but because each one of those groups uses hex. That means that they can use letters. So that allows us to use to have a much larger combination of addresses, which then leads to more IPv4 addresses. All right. IPv6 address types also use a CIDR notation with the dash and a number after the dash, which indicates the written address that makes up the network portion of the address. Within it, we have the address prefix, and that gives us the information that allows our devices to decide how that data is going to be moving. That's what the prefix does. We also have different ways that they're configured to communicate. The first one is link local unicast. I should probably erase that because that came out terrible. Link local let's use this. Link local unicast allows computers to connect to each other without using a router. So I am connected to you. There's no in between. A global can be routed as a public address on the internet through network and routers. So that's like your typical small office and home office configuration. Unique local unicast replaces the address type for what used to be a site local address type. So that means that I am communicating out from one computer to many computers. And then multicast is like an IPv4 multicast address that's used to broadcast messages throughout the entire network. Okay. IPv6 address types continued also include the special addresses. So just like in IPv4, we have a loopback. IPv6 has 2, which is the loopback address and then the unspecified address. The loopback address is again to test, and the unspecified address is also for testing purposes. IPv6 tunneling through IPv4. So if I am communicating out to you and you can only understand IPv4, I can wrap my message in an IPv4 wrapper as IPv6, and I can communicate with you. The way that you know what kind of address type you have is by looking at the slash and also looking at the prefix. A link local unicast typically uses FE80. A global unicast uses 2000. Unique local unicast uses FC00. Site local is FEC0. Multicast FF00. You're probably asking yourself, how am I going to remember all this? You're not. That's why I have a table here for you. All right. There's no shame in creating a cheat sheet to be able to remember all these different address prefixes. Okay. So how do we configure? How do we configure IPv6? Well, just like with IPv4, Windows has a way of automatically configuring it for you through dynamic means. However, you can also do it static. You can decide what specific IP address you have by using configuration commands. But it can be done in 2 different ways. There's a stateful and a stateless way. A stateful automatic address configuration, that's on one or more devices. They track the state of the client in the table. So it knows what the client is doing. Is it up, is it down? And then it assigns an IP address. A stateless automatic IG configuration allows the client to collect as many settings around it, and then it'll create a IPv6 address. So it knows the state. No, it doesn't know the state of the device. It knows the state of the entire network, and then it's able to assign an IP. Okay. To configure an IPv6 address, we can also use the NetSH in the ipconfig to show you how it's currently configured, and then we can go into the GUI, the graphical user interface, through either network settings or control panel in order to be able to configure the specific address. All right, so just like with IPv4, we need to be able to troubleshoot IPv6 settings and make sure that we are configured correctly. So, excuse me, it's very much like IPv4. First, we want to make sure that we are configured the right way. So we do that through the different commands that we discovered through either command line or PowerShell to just verify that the systems are configured the way we want. Then we want to ping it. We want to throw out a little rock just to make sure that we're able to reach out to the devices that we designated. We want to verify that the DNS server is actually associating the name of that we're trying to reach out to with the IP address of that actual device. And that's when we use the modifier tag6 and then the target name just to make sure. And then we verify the data connections just to make sure that they're actually happening. Okay. Internet connectivity. Depending on whether a single computer or multiple computers are using an internet connection, we'll decide how we will be able to connect. Think of everyone rushing into through a single door. Okay, how you connect, if it's either in an orderly fashion, whether it's one by one, or whether you are communicating in the right language, that's going to determine whether we are going to be able to leave the gateway and communicate, and what will be communicated in the capabilities of our communication. When we are connecting through a single computer, it's usually have to determine the medium. There are many different ways that we can communicate out to the internet. The first one, which in small office, home office computer, small office, home office computers, is not quite as typical. It's cabling. Every company offers some kind of Ethernet cable that you can connect to your modem and then connect it to your computer to give you that internet access. By default, whenever you connect directly through Ethernet, DHCP is going to be used to obtain an IP address. DSL is another way, the digital subscriber line. It's less common nowadays now that we're using fiber, but it allows us to use a connection over a phone line. That was back in the days, back in the 90s, like my daughter used to say, how we used to communicate through AOL, America Online. And it's using a protocol called point-to-point, which think of it as almost like peer-to-peer to be able to secure those connections. And then dial-up, oh man, don't even let me get you started on dial-up. It was just a much slower way of accessing the internet through your device, which was also going through your modem. It used to make a bunch of random noises. It was crazy. But nowadays, primarily when you connect at home, you connect them through wireless. In fact, whenever you arrive at a new location, the first thing you want to know is what is the Wi-Fi password. So that way that you are able to connect. It shoots up a wireless signal, and you're able to connect to that wireless signal and have the freedom of maneuver around the entire physical space. connections. Okay, there's also ad hoc. Ad hoc is now deprecated. It's also known as IEEE 802.11, and it's just another way to share wireless. But think of it, instead of you trying to share an internet connection, you're just trying to become the hub to make a connection between all the computers in the room. Okay, wireless hosted network allows you to turn your PC into a wireless hotspot so that you are able to connect out. And then Wi-Fi direct is just a way that two computers can communicate with each other. You're not sharing any resources. I'm communicating with you through Wi-Fi direct. Okay. If you go into network sharing, you can, or in network settings, you can see that you can set up your device as a hotspot, just like you would on your phone. Wireless hosted network, you can see all of the different protocols and security settings that you can use. If you use the NetSH WLAN show drivers command, you can see all of the different capabilities of your device. In this particular network, wireless networking device, we can see the name. We know that it's coming from Intel. We know what version it is. We know that it's a driver, and we see all of the different radio types that it can support. This also includes all of the different security encryption capabilities that it has. So here we have WPA, WPA2 is most secure, now WPA3, and so forth. Okay. Now we're getting into wireless networking. We all know what Wi-Fi is. We know that it's a way for us to be able to access a network. We usually associate it with internet, but Wi-Fi connectivity extends to more than just internet. It's just a way that we access any network wirelessly from our computers. We do that by connecting to what's called a WAP, or a wireless access point, which can be a base station, or like we just mentioned, it can be a computer that we can, any medium through which we can access to go out to the internet. Every single wireless access point has the security set identifier, so the wireless name. It'll tell you the mode that it's in, the 802.11 mode, so ABG, and that'll tell you the capabilities and also the security method, so how it's encrypted. The 802.11 mode will determine what kind of frequency it's going to be operating in. The two big popular ones are 5 gigahertz and 2.4 gigahertz. And as you can see, as we progress, we are able to also access higher throughput speeds. So we can go higher with the newer technologies. The latest one is now .11ax. That gives you not only 2.4 gigahertz band, 5 gigahertz band, but also the 6 gigahertz bands, and you can transmit up to 9,000 megabytes per second. Okay, that's a lot of space per second, a lot of bandwidth per second. How do we create a wireless signal? Well, tons of different ways. You can either connect to a wireless network. You can do it through the command line. You can do it through GUI. You can create one through a group policy, which we're going to go into Active Directory later. We can decide whether we want some kind of security, or do we want all of our credentials and all of our data flowing out there in the open. We can decide the name of the network. I've seen some pretty crafty ones. The type of security, and whether you are going to be able to connect directly to it or not. How do we manage it? Well, Windows likes to give us options. We can go into settings and then go into network sharing, and we will see this screen here on the right, or we can use, we can right click directly on the adapter, and this will give you this screen here, which will tell you all types of information about your status and how your device is connected. Now, how do we manage wireless connections? Continued. You guys have probably already heard of airplane mode, and that's basically just shutting down all of your wireless connections. That way it doesn't cause interference. That also extends to cellular and Bluetooth. And we want to do that. They call it airplane mode because everybody thinks that if you have those devices shooting out a signal, it's going to interrupt the connections with the aircraft down to the tower, and it could cause mid-air collisions. So airplane mode turns off all of your wireless connections. And then even from settings, you can set up your hotspot. Okay, How do we troubleshoot it? How do we troubleshoot a wireless connection? Well, we verify that the connection settings are turned on. Make sure you don't have airplane mode on. Consider that your network hardware might be messed up. Maybe that wireless adapter doesn't have the right driver. Maybe it doesn't have the right software. That you make sure that you're not getting any interference from any other devices around you, like a microwave or a power line or some other devices that are occupying the same frequency. Make sure that the 802.11 standard that you have isn't limited. So you think you're using AX when in reality you're using B, and that only limits you to a certain throughput and a certain frequency. Make sure that the Windows 10 client, it's actually connected to connect to that wireless access point, configured to connect to that wireless access point. Then you might want to reset your TCP/IP connections if that's so. If all of that stuff is true, just to make sure that you have a good IP, a good new IP. And then lastly, and I'm sure you've seen this troubleshooting step before, where they have you reset everything and then bring it on sequentially. To troubleshoot it, to troubleshoot a network, you can also use the tools in the graphical user interface. If you go into your settings and go into network settings, you can click on one of the network troubleshooting options, and it'll take you to a guided wizard that's going to assess what's going on within your network, and it's going to allow you to troubleshoot it and help you decide what's going on with it. Now, what is a firewall? It's a big old wall of fire. And its basic function is to protect your devices and protect your network. So Windows 10 has a built-in firewall functions, and you can use it to augment whatever other third-party firewall, either software or hardware you have in your network, to add another layer of protection. Okay. You can access the basic firewall configuration settings from the same basic network settings in network and sharing center, or from the control panel. And you want to also make sure that it is properly configured to only allow the things that you want it to allow, that you want to allow to communicate with the internal resources in your network. A program can be allowed access through the firewall depending on various things. It could be where it's currently located, or whether it's in a public setting or in a private setting. We sometimes have what's called an allow none or allow all rule, or deny all rule, that will only allow what you let it in, and everything else after that rule will be denied. So that's very useful for protecting your network resources. Again, you can either go into the control panel or through the GUI, through the network sharing center, in order to configure that firewall, and that's one of the things that we're going to do in our labs. Basic firewall configurations, here it is again through the control panel. From here you can specify, hey, I want remote assistance. I will allow that, but only from private networks. So that means only between, not from public. You can do a lot of really advanced things with a firewall. A lot of different configurations for the rules that you're gonna be that are gonna determine what's gonna come in and how it's gonna come in. So you can say, I will only allow connections from this device, but only if it's communicating in this way, so that your inbound and outbound connections, how you will allow communications to flow out, and how you will allow to communicate in. What kind of ports, what kind of services and protocols. I may not want people pinging, so I may not want ICMP to come into my system, because that can create what's called a DDoS, denial of service, the distributed denial of service attack, where they will try to overwhelm my systems with my ICMP pings, and we don't want that. Okay. This is what it typically looks like when you are configuring the firewall. We will actually be exploring this during our lab, but from here you can configure all of your different rules. You can create profiles for your firewall with pre-configured rules. You can import policies, you can export policies in case you want to apply those same settings to a different firewall. Here you can see the profile settings, what kind of state your firewall is going to be in, to include what connections is it going to allow, what connections is it going to allow to come in and also to come out. Okay. IPsec has to do with your IP and the type of security settings, so what kind of encryption is going to use to allow the connections to come in, whether they're going to be encrypted or out unencrypted. You definitely don't want anything leaving your network unencrypted, but yes. Okay. If you go into the Windows Defender firewall configuration here, it'll tell you very specifically what ports, what protocols, what services, what groups are allowed to communicate with what. Okay, here is another menu that allows you to configure all of your different rules, so not only the rule itself, what to allow in, but also all of the different properties, what can be allowed in and what's not, depending on security settings. So don't allow anything out that is not secure or isn't encrypted in some way. Here's the rule wizard. So you can say, what type of rule would you like to create? Well, I want to create a rule for a specific program. So let's say that Microsoft Word or something wants to communicate out to get a template from the cloud. I am going to set the rule type, what is the specific action, so I will let Microsoft Word only communicate out to this specific server and back. Allow the connection, don't allow the connection, only allow it if it's secure, or completely block connections. Okay. What type of connection security rule would you like to create? So is it going to completely isolate the system? Is it going to allow you to skip any authentication processes? Is it going to allow you to just communicate between specific computers? That's the level of granularity that you can get down with these rule types. Okay. I'm going to provide you with a copy of these slides as well this week. They're going to be on your Blackboard, but this is a copy of all of the different commandlets that you can use in PowerShell in order to configure your firewall rules. That includes configuring an entire rule and then disabling it. This is the monitoring view, so you can see what rules you've applied and whether they're active or not, and a little bit of information about what they allow in. Okay, so that kind of ends our class, our lecture for this week. I'm sure you may have a couple of questions. IPv4 and IPv6, just know that it's the number that your systems are assigned that uniquely identifies them. It's logical, which means that we can change it. It's not a physical thing like a MAC address that's hard-coded into a logical address, a logical name. Can be changed. It's very malleable. The first octet tells us what kind of class it is, and the class tells you what it's being used for. We know that 127 is loopback, right? So to test the system itself, and the class C is the typical address that you see in a small office, home office device. But just as a self-assessment, your company requires computers to authenticate to one another. And enforces this requirement with Windows Defender Firewall. We just went under with advanced security rules. You're asked to customize exceptions based on specific IP ranges. With what type of connection security rule can this be done? So the key thing is you're asked to customize exceptions based on specific IP ranges. So that is alluding to the security rule that only allows connections between specific classes of IPs, right? which protocol is used by the client for Microsoft Networks and file and printer sharing. Okay, what's the protocol for sharing? Or SMB. So it's the file shares and for printers. Okay. Right. So in summary, the network sharing center is this one of the central locations. You can also use it to control panel to view and access networking information. That's the one that Windows wants you to use. Okay. Windows 10 is network aware, so not only does it know the settings for your particular computer, but also for the network itself, for the network itself, and it uses that stateless, so stateful function to decide what kind of IP and how that connection is going to go. You can configure IPv4 and IPv6 to use specific gateways. You can configure Windows, or you can use command line to obtain how your system is configured, all of the configuration settings. We learned about IPv6 and the need for more complex addressing so that we can account for the many devices that are being used in the internet. We know how the internet connectivity service configures Windows as a router, so that you can share your connection with other devices, kind of like as a wireless hotspot. And we learned quite a bit about the firewall. The firewall is how we protect our network, and the rules in there allows us to determine what gets in and what gets out of our network.